Problem 117 is part of the in-class work. So going over this one, we're saying that the previous problem, that they made a mistake, and instead of it being plus 10 at the end, it was actually plus 18. That means now that there was an 8 remaining. So the significance of this 8, well, first of all, it means it did not divide evenly into that. So when you divided the polynomials, they did not divide evenly. This 8 is then the remainder. That's actually what they start talking about here in problem B. So thinking quickly about a remainder, if we take, let's say something like 36 and we divide it by 4, that divides evenly and we get an answer of 9. But instead, what if we did that and divided it by 37? So 37 divided by 4, that does not divide evenly. So instead, we have a 9, but we have 1 left over. So that would be, it would be 9 remainder 1. But we don't write it like that. Since we got out of elementary school, we wrote it as 9 1/4. So this 4 down here is because that's what we were dividing by. So that one over here. The 1 was the remainder. So what they're doing now when they're talking about remainders is that problem B, instead of using the word remainder like I did in this example here, instead of actually doing that, we can write the remainder as a fraction over the divisor. So for example, when I look back at problem B now, so the answer was 3x squared minus 4x plus 2, but it had a remainder of 8. So instead of writing remainder 8, we're going to write plus 8 divided by the 2x plus 5. That is now the answer. So now we're going to do problem C. We're going to set up our generic rectangle, do our polynomial division, and on this one we're going to get a remainder. So we need to write that remainder out. If you've not already done this, maybe you want to pause this now and set the problem up and try it yourself, and then double check your work. All right, so the 3x plus 1 I put on the side over here. Remember, these are just generic rectangles. I don't go through and make another box over here and call this A and B and then put my multiplication symbol. I don't do all that stuff. I just make it a generic rectangle. I also don't put my vertical stripes in here as well because I don't really know how long that box is going to be. So I just start off with my first term, and you should always start off with your first term in the top left. Do not start with the -1 down here and work the other direction. And the reason why is because when you have a remainder, this will never work out if you start with that. So I'm starting with that 6x cubed, and now I block that off and I figure out what goes up top. Well, 3x times a 2x squared will give me 6x cubed, so I've now figured out what's on top. That now allows me to figure out this box here, which is then going to be 2x squared times 1, which is just 2x squared. So 2x squared plus whatever I put here has to equal my 11x squared. So that means I have to have a 9x squared here. That means I can now figure out what goes up top. Once I figure out what goes out top, I multiply it by this, and I can figure out this box. So the top is going to end up being a positive 3x. Multiplying it to 1, I get 3x for that box. 3x plus this one has to equal a negative 12x. That means it has to be a negative 15x here, which means up top has to be minus 5. Negative 5 times 1 gives me a negative 5 here. But here's the problem. This bottom number in this box is supposed to be a negative 1. It is not a negative 1. So I just continue the same process that I did. I just add another box over here and say if I add these together, they need to equal a negative 1. So that box has to be then my remainder of positive 4. So when I do the polynomial division here, my answer to that is what's up top with this remainder. So the answer is 2x squared plus 3x minus 5 plus 4 over 3x plus 1. Again, the 4 is the remainder. The 3x plus 1 came from what I was dividing by.